Okay, so yesterday we went over the rules for stretches and compressions and what is going to happen to the graph. I just want to go over a few clarifying things. So for anything that's horizontal, whether it's the stretch or compression, we have this affecting the y-axis. So points are being pulled away from the y-axis or pulled towards the y-axis. But because it's horizontal, it's the x-coordinate that's going to change. So we're just going to add that above. So if it's horizontal, it's the x-coordinate that changes. So will you guys add that to the top of yours for me? Oh, sorry. Can't see that. The x-coordinate changes. And because the x-coordinate changes, that is what produces that wider graph. Okay, if it's a stretch. If it is a compression, then it's going to be narrower. If it is vertical, then the y-coordinate changes. Okay, we multiply the y-coordinates by what we call the variable a. A and b are called factors. So I'm just going to add that to the bottom. A and B are factors. So factor is something that you're going to see today as we go over the stretches and compressions. There might be a vertical stretch by a factor of 5 or a horizontal compression by a factor of 3/4. Okay, remember that if it's a compression, those values have to be between 0 and 1 or -1 and 0. And then if it's a stretch, the absolute value would be greater than 1. So that could be a +5 or it could be a -5. They're both going to produce a stretch. Okay? All right. So I do my best to use the same directions that you're going to see in your homework for our practice problems. So for our example today, it says use a table to perform each transformation of y equals f of x. Use the same coordinate plane as the original function. Now the way that the original function is going to be presented to you is in graph form. If it says use a table, I expect there to be a table on your homework practice problems. So we're going to go over how that should look. Oh, I also just want to show you that you do have this chart in your book on page 9 that looks very similar to the one that we did. And you can see here, if it's vertical, y-coordinate changes. If it's horizontal, the x-coordinate changes. And then they have some numerical examples in there. We don't have that because we're going to be practicing that together. All right, so for your practice problems, you would be given a graph. We are going to be using this graph. And what we're going to do is we're going to pick some points off of that graph. So what you would be doing in your homework is you could pick any points that you wanted. I suggest using at least 4. Is that even moving? I'm trying to zoom in on it. Okay. I'm just zooming in. All right, so we're going to pick 4 points from this graph. So take a moment to look at it. I know for some of you it's kind of long, so people who can see it better are going to be helping us out. And we want to pick points that are going to help us with the shape of the graph. Okay, are there any points that you guys notice that would help us graph it? Yeah. Yeah?
So I'm trying to figure out what that would be. Negative 1, 3.
Yes, -1, 3. Okay, so that's one of the ones that we're going to use. What's another one? Yeah.
4, 2.
Good. 4, 2. What's another one? Yep. 2, 2. And then the last one that we're going to use, what do you guys think? Yeah. 0, 0. Okay, perfect. Good. Those are the exact ones that I picked, so you guys did a great job. So, again, at the least amount, I want you to choose 4. There might be some graphs, depending on their shape, that you would want maybe 5 points. Okay, so for the original function, I want you to put that graph, or that table. And then we are going to draw a rough shape of the graph before we actually graph that. Okay, nice job. All right, and then the shape of our graph, I'm going to help you with it. The shape of this graph, I know, looks a little bit different, but it's actually pieces of functions you already know, because this is what type of function? It has a slope, but it's called a linear function. And then there's this little curve, which is kind of like the curve of what? A parabola, yeah? And then we have the horizontal line, which is also linear. This type of function we'll learn about in the second semester. It's called a piecewise function, because you take pieces of different functions and you put them together. Okay, so now we're gonna graph that on parts A and B. Okay, so then you're gonna flip the paper over, and then I want you to use those 4 points. Okay, if you want to use a straight edge, if you have one, you can. If you want to grab them from the back, that's fine too. If you're like, I'm going to wing it today, I'm cool with that as well. So whatever you're feeling. All right, so -1, 1, 2, 3, 0, 0, 2, 2, and then 4, 2. So when you're doing this, just make sure you keep the integrity of the shape. You can put the arrow on the end here. And by the integrity of the shape, I mean make sure that you curve this up. That's not a straight line there. Okay? And then have your arrow go on there. Okay, and then let's do the same thing for part B as well. So -1, 1, 2, 3, 0, 0, 2, 2, 4, 2. So we have our original for both of them. And then once you've done that, go ahead and read through the steps. We're going to work our way through them together. Alright, and then I did add what the directions are for part A. So for part A, we are going to perform a horizontal stretch by a factor of 3. Horizontal stretch by a factor of 3. Alright, so if we look at our steps, with the steps, when we're doing our notes, I do expect you to write out what I'm writing out. For your homework, you're not going to have to write out everything that we do in our notes, but I want your notes to be a good blueprint of how we got to the places we're going. Okay, and I'll kind of talk you through, okay, you don't have to do this part on your homework, but remember the directions do say that you need to use a table, so you should have a table for every graph that you're making. So the step 1 is pick the 4 points from the original graph. Guess what? We already did that. So that's what we did on the first page. So I'm just going to write down those original points, so do that with me for this. So we picked 4 points. They do show that original shape. And then step 2 says use the chart from the notes, or it is on page 9 of your textbook, to determine the changes in the graph. So what I mean by that is I want you to find the rule. So for this one, it's a horizontal stretch. So horizontal stretch, the factor is 3. So if I go to find my rule, all I have to do is look on my chart for the horizontal stretch, which is my first box here. So the horizontal stretch, this is my rule. XY goes to BXY. So we're just going to write down the rule, okay? XY goes to BXY. Alright, so I know it's a horizontal stretch. The factor is 3. What variable is 3 going to be substituted in for? Yeah?
B.
B. Okay, so your factor is B. B is 3. Which means you are going to multiply the x coordinates by 3. What's going to happen with the y? Stays the same. Okay, so step 2 is something I want you to have in your notes, but this isn't something I'm going to expect you to write out for every problem. You're going to be able to see it's a horizontal stretch, the factor of 3. So you can go straight from, on your homework, the original to the transformation. Okay, which is step 3. So step 3 is writing the new points after the transformations are applied. Okay, so I'm just going to make a little start. Step 3, you have to have this chart for this, okay? Alright, well we said the transformation is multiplying the x coordinates by 3. So I like to put these next to each other so I can do that really quickly. So let's multiply them all by 3. So negative 1 times 3 is negative 3. 0 times 3, 0. 2 times 3, 6. And, oh, what did I do wrong? Why didn't you help me? Yes, it's supposed to be 4, 2. See? It's okay. We make mistakes sometimes. It's 4, 2 is the original, right?
Yep.
Okay, and I would have realized that too if I graphed it, because then that wouldn't have looked correct. All right, and then 4 times 3 is 12. All right, and then the rest stay the same. So this is still going to be 3. This is still going to be 0. This will be 2. This will be 2. So now we can graph the new one. Okay, so we wrote the new points. And then if you want to use different colors, you can. So for your work on your homework, I'd like you to use pencil. But for the graphs, if you want to use some colors for the graphs, I'm fine with that.
What if you wanted to like change the points, like make like one big square and like one big circles?
Like on the
If
graphs.
that makes any sense?
Maybe solid and dash would be good. That'd be fine. And then this is off of our chart, so we're going to go 1, 2. With your graph paper, you won't have to worry about that part. And then after you graph it, I would use your chart again and just make sure that it fits that narrative. Is it wider or is it narrower? And then again, remember this is a curve, and this part is straight. Okay, so this is wider. Is that what our chart says for horizontal stretch? Should it be wider? Yep. Okay, because when you're stretching horizontally, did I do this yesterday? Think about people like pulling your arms out. You're getting wider. Okay, excellent. Do you guys want to try the second one on your own? I think you can do it. The vertical, we're doing a vertical compression by a factor of 1/2. Okay, do you guys have any questions for me about part A?
Did you graph the, it feels like you did -2, 3 instead of -3.
I did. Thank you. Yes. 1, 2, 3, 1, 2, 3. Which is nice because it will be even wider. Need some white out, right? Here, look at this one. I did a good job there. Thank you for telling me. Yes. All right. So, part B, vertical compression by a factor of 1/2. You guys want to get that rocking and rolling? So we know the original, right? Do you guys have the original already down? And I like to see mine. With yours, you're going to be using the same graph, so whichever points you choose, you're going to get those pretty good in your head, so you don't have to write that down every time. Okay, so I want you to find the rule for the vertical compression, and then if you can do the new chart for the transformation, that would be great. Okay, and I'll give you a few minutes to try that by yourself, and I'll come around, and then we'll check and make sure that we all got it. And then, if you finish, if you want to grab your algebra review packet and have that out on your desk, I'm just going to come around and see how that went. What are some things we might need to talk about?